We have to prove this relationship using mathematical induction for all n is equal to greater than 1. So as the first step we will show it for n is equal to 1. So that's the step 1 we can say for mathematical induction method. So when n is equal to 1, left hand side is minus 2 into 1, so that's just minus 2, and right hand side becomes minus 1, 1 plus 1, which is minus 2. So left hand side is equal to right hand side for n is equal to 1. That's proved. Now as the step 2 is the assumption that the relationship is true for n is equal to k, well, when k is any integer greater than or equals to 1. So when that happens, we assume that the relationship is true. So we say that this one minus 2k is equal to minus k plus 1, because we are assuming that it is true. Now, having assumed that, with that assumption we go to step 3 to see what happens when n is equal to k plus 1, and when that happens we see what is the left hand side, which is we will replace n with k plus 1. So minus 2, minus 4, minus 6, minus 2k, then minus 2k plus 1. This is the left hand side. Now we have assumed that for n is equal to k, the left hand side is equal to right hand side, and this one is the left hand side when for n is equal to k, up to this much when n is equal to k. So instead of this one we can write, instead of the series we can write the right hand side here. So we can write minus k plus 1 for the series, and then the k plus 1th term as like that. Now what we will do, we can take minus k plus 1 and then it becomes k plus 2, like that. So this is our left hand side. Now for n is equal to k plus 1, we look at what is the right hand side, and that will be minus n plus 1 was the right hand side, given right hand side, and when n is equal to k plus 1, it becomes, instead of n we will write k plus 1, so it actually becomes k plus 2, which is the left hand side. So we have shown that the relationship is true. The left hand side is equal to right hand side for n is k plus 1 when n is k, with the assumption that when n is equal to k the relationship is true. So basically with these steps we have shown that the relationship is true using mathematical induction. In the step 1 it was shown that it is true for n is equal to 1, the first natural number. Then it was assumed that for n is equal to k, for when k is any natural number, the relationship is true, and with this assumption we have shown that if that is true, then the relationship is true for the next natural number, and so it is proved, the relationship is proved for all n is equal to 1 and greater than 1.